Ladies and gentlemen, welcome to the third lesson for electric circuit. If you are watching this lesson, please go and watch the first lesson, the second lesson which is posted. This is the third one. The first lesson explained electric circuits from grade 10 and 11 perspective. And the second section of the first lesson, it explains how to interpret an electric circuit. It teaches you the basic things which you need to know in order for you to interpret any circuit. It teaches you that current cannot flow in an open circuit. It tells you that current is divided under parallel connection and many other things which are basic, which we will use in this third lesson. The second lesson, it further explains how we interpret the electric circuit. This is the third lesson. Under the third lesson, we're going to introduce many concepts which are supposed to be taught, which are new in grade 12, which is the internal resistance. Because in grade 10 and in grade 11, they make an assumption and they ignore the internal resistance. And in real life, in a real battery, each and every battery have got internal resistance. So we move. Okay, in the second lesson, we were making a demonstration of power. We spoke about power. We said power is given by this formula, VI, the voltage and the current, right? Okay, I just want to put some emphasis. Okay, so let us recap this. And I told you that from this formula we can use the Ohm's law and drive to get many different formulas from this, right? Whereby power, we can say voltage is when we want to get the voltage, we multiply the current and the resistance, meaning we can say here we have I, R. This I is already here, then I multiplied by everything, we're going to get I squared, meaning power is equals to I squared R. Also, we can use the very same formula whereby we say I from Ohm's law, which is the current, is V over R, voltage over resistance, whereby we're going to multiply by voltage over resistance, which is the current, whereby power is equals to V squared over R. So these are the formulas that we derive from power. And I told you that you don't need to cram all these formulas. Knowing this one and knowing this triangle for Ohm's law, you can be able to produce all these different formulas. But one thing that I want us to touch, it is the issue of the SI unit for power. The SI unit for power is what? Is joule, right? It's joules. But usually in electricity, we use watts. In electricity, we use what? Watts. So watts, which is the letter W, joule is letter J. So you need to know that one joule is equals to 1 watt. Understand, right? Yeah. So if you find that they gave you 20 watt, you just need to know that 20 watt is equals to 20 joules. Understand? Yes. The problem will come when they give you what? Kilowatt, right? When they give you kilowatt, you know that kilo is 1000, right? So it means you need to go back to what? To watt. Whereby what will you do if you are given, let's say you are given 2 kilowatt. It means you need to multiply, right? By what? 1000 to go to watt. Because when you move from the biggest to the smallest, you do what? You multiply. Because the smaller number for the biggest value must be equals to a very large number of the smallest value. I mean, 2 kilowatt must be equals to how much? 200, right? 2000, not 200, 2000, because we multiply by 1000, you understand? So that's what I wanted to put some emphasis on, that the power is given in watt. You understand? If you can have an electric circuit and you are given the watt, which are represented by letter W, you need to know that that is your power. Understand? 1 watt is equals to 1 joule. So this is just a recap from what we did in the second lesson. So now we are introducing the third lesson. Okay, so today I want us to introduce grade 12 content for electric circuit, which is specific for grade 12. I want us to talk about what we call internal resistance. Internal resistance. And you need to know that even in grade 10 and 11, because we're dealing with real thing, internal resistance is there. It's just that in those levels, they ignore the internal resistance. Because in reality, each and every battery have got resistance. So you need to know that a battery or a cell of a battery, it have got terminals. It have got the terminals, right? So those terminals, they create a particular resistance inside of the battery. You understand? So as current is moving in the battery, there will be some sort of resistance which is inside that battery. So we call that resistance to be internal resistance. So each and every battery, naturally by itself, it have got its own resistance, and that resistance is called the what? The internal resistance. They say terminal of a battery have internal resistance. So what does internal resistance do to a battery? Let's say we have a battery, a car battery, a car battery have got two nipples. The one which is positive and the other is negative. Well, good, right? So, these are terminal, positive and negative terminal. So, we know that this battery is going to derive current so that current can be driven. Charges can start to move because current is charges, right? So, inside this battery, there will be internal resistance. So, this internal resistance will cause some of the energy that is in the battery to be converted to heat. That's why when you plug and you use your battery, you will find that the battery gets warm. The battery becomes warm because of internal resistance. Internal resistance causes some of the energy in the battery to be lost in the form of heat, meaning that the internal resistance causes the energy that the battery can deliver to be lost in the form of heat. That's why you'll find that the battery is becoming warm. So you can come across a question where they ask that, why is the battery warm? The battery gets warm because of internal resistance, which is causing some of the energy inside the battery to be lost. And it is lost in the form of heat. And when it is lost in that form of heat, it cannot be converted back. You understand? So, you need to know that internal resistance affects the battery by causing some of the energy in the battery to be lost in the form of heat. Okay, so we're going to talk about this information into details. Okay, for you to understand the language, we use lowercase r. Since you know that English is not our home language, we call it small r. So this is a small r, a lowercase r. The lowercase r, it represents what? Internal resistance. Internal resistance. Because you know we've been using the letter R, and that letter R, it was a capital. So in this case, the capital R will be representing external resistance. External resistance. So internal resistance, we use lowercase r. External resistance, we use uppercase R. You understand? So some they even write R-E-X-T. E-X-T, which stands for external. What is external resistance? External resistance is the resistance that we've been talking about ever since the start of the lesson. The resistance that we've been talking about when we were in grade 10. The resistance that we have been talking about when we were doing grade 11. That is external resistance. In an electric circuit, we represent external resistance like this. We know that we've been representing our resistance like this. We've been saying this is resistance. So do not be shocked that now they've introduced external resistance. No, the resistance that we've been dealing with, it is external resistance. This is a resistor. There is external resistance. This is a resistor. There's external resistance. You understand? Yeah. So internal resistance, it is the resistance which is inside the battery itself. So they usually represent it like this. They will draw a box that is a representation. They will draw a box and they write a lowercase r, small letter r. And this small letter r, it represents the what? The resistance. So that's what you need to know. It is internal resistance. Although they write it outside of the battery because this is just a representation, you need to know that this resistance, it is inside the cell of a battery, and it does what? It causes the battery to lose some of the energy in the form of heat. That's why if you have connected the battery to some wires, you'll find that the battery is becoming warm. We know Wi-Fi, sometimes we hotspot people. You will find that your gadgets start to be warm. The reason that your gadgets start to be warm is because some of the energy is being lost in the form of heat. That's why your gadget will become warm. So sometimes you check the battery, you feel the battery, you find that the battery is warm. Whether it's a battery of a car or any battery. If a car, the ignition is on for the car, if you feel the battery, you find that the battery is warm because of internal resistance. It will cause some of the energy to be lost in the form of heat. We are good, right? Okay, so this information of internal resistance and external resistance will lead us to the following information. There's what we call V load and V external. Because now we'll be dealing with information which we get because of internal resistance and external resistance. So that will lead us to V load. V load, this V is just the voltage. So this V load, okay, I can say that, you see this external resistance is also called the load. It is also called the load. So when we say V load is the voltage. Is the voltage from external resistors. Resistors, right? V load is the voltage from external resistors. V load. This is the voltage that we're going to record from the external resistors. Let's take we have an electric circuit here, and this is a resistor. There are two resistors which are connected in series. The voltage that is going to be recorded here plus the voltage that is going to be recorded here, we call them the V load. Then the voltage which we're going to record here it is different from the voltage that is here and here. Remember, for instance, thing we've talked about that the voltage in series, it is not the same in different resistors, right? So the voltage that is here and here, when we sum them, we're going to have V load. V load is the voltage experienced by the what? By the external resistor. Is the voltage that we get from external resistor. Then there's what we call V internal. V internal. V internal, you can say V internal resistance. This is the voltage that we record from the internal resistor. Understand? This is the voltage that we record from the resistor. So we've introduced two things, R external and lowercase r, which is the internal resistance. So now we come and talk about the voltage of the load and the voltage of the internal resistance. The load is the external resistance. Remember in the first lesson when I was teaching you, I told you that the things that you plug at home, those things are resistors. So your fridge is a resistor. Your stove is a resistor. Your plasma TV is a resistor. So that's how we call them load. Because when you plug them in that meter box, you have increased the what? The load. You understand? So that is what is happening. I hope we are all in the right track. No one is confused. If you have questions, you can ask. Okay, let us continue. And that internal resistor, it leads us to what we call EMF. It leads to what we call EMF. Now, EMF is measured in voltage, in volts. It's measured in volts. EMF is measured in volts. And what you need to know, you will be asked in your exam to define EMF. What is EMF? We know that whenever we define any concept, we don't just use a definition from any textbook or from Google. We use a definition from the exam guidelines. Even in universities, different universities, when it comes to referencing, they use different types of referencing. So when you get there to the university, they will tell you that in this university, we use Harvard style. In this university, we use this type of referencing. So they will expect that when you write your dissertation and everything, you reference according to the culture that the university uses. The same apply in education. We know that all those definitions they provided by scholars are true, but was specific. We want you to use the ones that are in the exam guidelines. So this is the culture in education that we are allowed to specify what to use. Okay, so what is EMF? It is examinable. You'll find it in your exam. EMF is the maximum energy. EMF is the maximum energy provided by a battery. The maximum energy provided by a battery per unit charge passing through it. So EMF is the maximum energy provided by a battery per unit charge passing through it. I want to explain what is happening with this EMF. I've already told you that EMF is measured in volts. and it is the maximum energy provided by a battery per unit charge passing through it. That's how we expect you to define or state it in your exam, because that is according to the South African exam guideline, EMF. Okay, we need to explain what is happening with this EMF. Okay, I've told you that we're talking about EMF. It is all because of the internal resistance. Okay, let's say we have a battery. Let's say we have a battery, and this is the nipple of a battery. The nipple of a battery, of a cell, right? Okay, well, good, right? Okay, so now, let's say we are told that this battery it can deliver what? 2 volt. Then it means that this 2 volt is the EMF. This battery can deliver 2 volt. That is the maximum energy that this battery can provide. But there is a problem. It does not mean that, okay, let me just draw something informally so that you can understand. Resistor number 2. Okay, I'm drawing this so that you can understand. I was supposed to draw a cell here, right? So I've drawn the battery itself so that you can understand. This is for the sake of explaining. So I'm saying that this battery can deliver how much? 2 volt. And I'm saying that that 2 volt is the EMF. So note that EMF is the maximum energy that the battery can provide per unit charge passing through it, right? Yeah. But look, since this battery can deliver 2 volt, it does not mean that the voltage that is going to circulate in this circuit, it is going to be 2 volt. The EMF is 2 volt, yes, but it does not mean that we're going to have 2 volt circulating in this circuit. Why? Because of internal resistance. Internal resistance. What will internal resistance do? I've already told you that inside the battery there is internal resistance. That internal resistance will cause some of the energy to be lost in the form of heat. That's why, as we've connected this battery in this cell, the battery will start to become warm, right? It is become warm because some of the energy is being lost in the form of heat. So if this battery can provide 2 volt, it does not mean that we're going to have 2 volt that is going to circulate here. It is possible that we may have what? We may have 1,8 circulating in the whole circuit. What happened to the 0,2? It was lost in the form of heat because of what? Internal resistance. I hope you understand. So, note that when you are given EMF, it does not mean that that whole EMF, it is the one which will be circulating in the circuit. That EMF is going to be reduced. Why is it being reduced? Because the battery itself have got internal resistance, and that internal resistance will cause some of the energy to be lost in the form of heat. That's why the battery will become warm. I hope I'm explaining everything, and I hope people are understanding. Okay. Okay, ladies and gentlemen, we are continuing. I was just explaining how does EMF work. I told you that if a battery can supply 20 volt and it is written on it 20 volt, it does not mean that in that circuit we're going to have 20 volt. Some of the energy is going to be lost in the form of heat. That's why the battery will be warm because of the internal resistance. So you find that if a battery can supply the maximum of 20 volt or the energy of 20, it does not mean that we'll have 20 in the circuit. Some of the energy is going to be lost because of internal resistance, and you find that we get 18, not 20. You find that 2 is lost because of internal resistance, and it is not lost in the form of heat. And that leads us to what we call terminal voltage. Terminal voltage. Terminal voltage is nothing, it's V load. Terminal voltage is nothing, is V load. We've already spoken about terminal voltage. They say that the potential difference across the terminals of a battery. This is the what? The potential difference across the terminals of a battery. Terminal voltage is the potential difference across the terminal of a battery. So, terminal voltage, I'm telling you that this is V load, right? This is the voltage that we record from the external resistance. Listen to this statement. Remember, the first statement in the first question was that current does not move in an open circuit, right? So this statement, I think they connect, are related. They say that when a battery is not delivering current, then the terminal voltage is equals to EMF. When the battery is not delivering current, I can write that statement. When the battery is not delivering current. You who are watching, I wrote when the battery is not delivering current. When the battery is not delivering current, the terminal voltage is equals to EMF. When the battery is not delivering current, the terminal voltage is equals to EMF. Okay. I'm saying that when the battery is not delivering current, the terminal voltage is equals to the EMF. Why is that? It's because the battery is not delivering current. There is no energy that is going to be lost, right? There's no energy that is going to be lost. But what will happen? Immediately, the battery starts to deliver current. Some of the energy will be lost in the form of heat. Then it means the energy that will be circulating in the circuit will not be the same as the maximum energy that the battery can provide. Some of the energy would have been lost because of heat. Let me read this. When the battery delivers current, the terminal voltage is less than EMF because some of the energy is lost in the form of heat. Because the internal resistance, the battery does work to move charges. You know that the battery does work to move charges. That's what we explained in the first session when we were talking about the potential difference, right? That it is the potential difference is the work done to move charges from one point to another. You remember, right? Okay. So immediately the battery starts to deliver current. The battery is going to do work, and some of the energy is going to be lost because of internal resistance. And then the EMF is not going to be the same as the voltage that is circulating in that circuit, that is driving the charges in the circuit. So it leads us to what we call terminal voltage, as I explained to you. Okay. You know, I can explain this situation like this. I can explain that situation like this. Okay. Let's say we have this electric circuit. Then here we've got EMF of 20. We've got EMF of 20, right? It means the current is not circulating, right? How do we see that the current is not circulating? Because the switch is open. This circuit is incomplete. A circuit is complete when current can circulate like this, right? If we're going to have something which is cutting the two wires, this current is not going to circulate. As if a cable at your home can be cut, one part of the cable is cut within the two cables. Your stove is not going to work because the circuit is not complete. So that is what is happening. So it means that the terminal voltage will be equals to what? 20. You understand?
Yeah.
Will be equals to 20. The terminal voltage will be equals to the EMF. But immediately we close this switch. Immediately we do what? We close the switch. Will we have a reading of 20 here? No, we're not going to have a reading of 20 because some of the energy is lost in the form of heat. We don't know how much we'll be having here, but we know it will not be 20. Understand? So do not confuse EMF and the V load, because some energy get lost in the form of heat. So as I've told you that the issue of terminal voltage, it relates more with the statement that we made the first lesson, that current does not flow in an incomplete circuit. So all this information that I showed you, it leads us to the following. I've already introduced EMF to you and I said it is examinable. It leads us to calculations and formula, which says E, which represents the what? The EMF. So it leads us to a formula which says EMF is equals to V load plus V internal resistance. Internal resistance. The EMF is equal to the voltage that is recorded from external resistance and the voltage that is recorded from internal resistance. That is the sum of them. It is the what? The EMF. It means this V internal resistance, this is the voltage which were lost, right? The voltage which were lost. Because E is the total, the maximum energy that the battery can provide. You understand? Yeah. Okay. From Ohm's law, we know that V is the same as, okay, let me make the triangle of Ohm's law. V, I, R. V, I, R. From Ohm's law, we know that V is the same as the product of current and the resistance, meaning that for V load we can write I, R. Notice that I'm writing capital R, because capital R is the external resistance. Because V load, remember V load is the voltage reading from external resistors. You understand, right? Yes. That's why I'm using capital R. But here I will use I small r. You understand, right? Mm-hmm. So this is the formula. So we can simplify this formula since we are mathematicians. You can see we've got I, which is a common factor, right? You can take it out and we're going to have capital R and small letter r. So this is the formula to calculate the what? To calculate the EMF. You understand? Yeah. So I'm not going to say throw this formula if these formulas can work, because some other time you will be requested to calculate the V load. So you can use it like this, or like this. And now these formulas, all of them, they are true. You can use them. Okay, we're good, right? Yeah. So it means if we want to get V load, you can just deal with this information unknown IR. Meaning that the voltage that is going to be in the external resistance, we can just multiply the current and the total resistance. You understand, right? Let's say we have got an electric circuit. Here is an electric circuit which is in series. So it means the voltage that is here plus the voltage that is here. How can we calculate it? How can we calculate it? It means we're going to say the total current we multiply with the total resistance. Then we'll get the V load. Understand?
Yeah.
So that is the application. It means also if we want to get V internal is equals to I small letter R. Understand that, right?
Yeah.
So that's how we interpret the electric circuit. So now I'm going to give a real scenario. And we work it out. Now we're starting. We're moving toward the learner-oriented. I think this will be the last lesson whereby it will focus on the teacher. The teacher delivering the lesson alone. Now it will be you. I'm including you because I've explained the content, the interpretation. So now you have now to show that you have understood what I've been teaching you through working questions. So now I'm going to write an electric circuit, we'll analyze it and we'll deal with it. I think that will be the conclusion for the teacher-oriented. After that, it will be you doing the work. Thank you. Let me give you the electric circuit, which is real, which we must work on it using what I've taught you from lesson number 1. Okay, ladies and gentlemen, the first electric circuit, which is real, which is not given ideal numbers in order for me to teach you. This is a real circuit set by an examiner, which I want us to interpret and work on it. Take note, all the circuits that I've been drawing, they are made by me. Even the numbers, I just thought of any number and wrote. It was for the sake of teaching you. All those circuits are not real circuits. I was teaching to explain to you. So this is a real circuit. So the type of circuits which are going to be set for you is this type. So take note. Okay. So here we've got an electric circuit. They say that 3 electrical devices X, Y, Z are connected to a 24-volt battery with internal resistance R. As shown in the diagram, the power rating of each of the devices X, Y, Z are indicated in the diagram. The power for X is 100 watt, the power for Y is 150 watt, the power for Z were not given. Here is the important information. Switch S1 is closed. When they say S1 is closed, it means this is what happened. S1 is closed. So let us just close it so that we understand. So the switch now is closed, meaning that current is going to flow here, but here it won't come because S2 remain open. We are good, right? So it means what is the reading of the current here? The current is 0. Current does not flow in an incomplete circuit. So the reading of current here and here it's a particular number which you don't know, which we need to calculate, right? Yeah. Okay. So now they say calculate current at X. And the information that were given 20 volts. Tell me the voltage that is here is how much? It's 20, right?
Yeah.
Because this resistor and this resistor, they are parallel. Parallel resistor, they've got the same voltage. The voltage that is here and here is 20. It means even the voltage that is here is 20. So now, they say calculate current at X. At X were given the power and then voltage. So, from the formulas of power, we look for the formula which have got current, right? And that formula is P is equals to V I. It's straightforward, this one. Can you see it? It has got voltage and current and power. And power were already given. Meaning that if we want to calculate for current, we just say our power, which is already in watts, 100 watts is equals to 20 volts multiplied by current. Then we divide by 20. It means current is equals to 5 amperes. Current is equals to 5 amperes. This is the first one. It means the current that is here is 5 amperes, right? Tell me, the current that is here, is it the same with the current that is here? It is not the same, right?
Yeah.
Because you know that the current is what? Is divided. The current is divided because this is a parallel connection. I repeat, this circuit has got a reading of 0 current because the switch is open here, meaning that this electric circuit will focus on this to this one. There's nothing that is happening here because it is open here, meaning there's no current that is going to come this side. We're good, right?
Yeah.
Okay. So now we come to the second one. We say the resistance of Y, the resistance of this one. We need the resistance of this one, right? So if we want to calculate the resistance of that one, we are given the power. And we already know what? The voltage of here, because the voltage of parallel resistors is the same. Meaning that we're going to use a formula which says P is equals to, we can even drive the formula quickly. You can say P is equals to VI, whereby P is equals to V. V is the same as IR, right? V is the same as what? So it means V is equals to IR, then P is equals to I square R. Are we good? This is also a formula which we can use to calculate the what? The resistance, right? But the problem about this formula is one. The problem about this formula is that we do not have the current here. We don't have the current. Meaning that it is easy, we can calculate the current. How do we calculate the current for that one? We are given the voltage and the what? And the power. We are given the voltage and the what? And the power. So we can just use this formula to calculate the what? To calculate the current that is here. Then we'll use this formula to calculate the what? The resistance. Okay. So let's just quickly calculate the current. We are requested to calculate the resistance, but we won't be able to do it according to the knowledge that we have so far. We can just calculate the current. That's then we'll go to the resistance. Power is what? 150. Voltage is 20 volt. How do we know that the voltage is 20 volt here? Resistors that are parallel, they've got equal voltage. So we know that from theory. We know that from theory. So we're going to have 20, and then we divide by 20. Then our answer will be I is equals to 150 divided by 20 will give us 7,5. 7,5 what? Amperes. You must not forget to write there aside units. Amperes. We're good, right?
Yeah.
So it means the current that is passing through here it is how much? 7,5. Right?
Yeah.
Okay. We're good, right?
Yeah.
Okay. So now what do we do? Let us calculate the what? The resistance. Give me a chance to erase this. I'm erasing this to use this space. I hope even you who are watching, you have recorded this information. I'm erasing it. We'll need it later. Then I'm moving here. I'm writing at the top, continuing this one at the top. So we have the current and the voltage. You can say resistance is V over I, right? I don't need to even use the power because we already have the voltage. So we can say voltage is 20 over 7,5, whereby our R is going to give us 2,67. So it means the resistance that is here is how much? 2,67. The resistance that is here is 2,67. So we got 2,67 ohms, right?
Yeah.
Okay, tell me, can we be able to know the total current in this circuit? If we want to know the total current in this circuit, what do we do? We add the current that is here and the current that is here. It will be the total current. Remember, we will not include this one because the circuit is open. There is no current that is circulating here, right? We're good, right? This is like what? It's like a reservoir, Joe. A very big reservoir. Okay. Ladies and gentlemen, I was talking about the JoJo. That if we have a JoJo, and this JoJo is connected to a pipe, it is connected to a pipe, right?
Yeah.
Then on this pipe, there is another pipe which is connected going to a different direction, right? It is the parallel connection. Water is going to move from the JoJo. It goes this side, and another amount of water, it goes this side, right? If we want to know the total amount of water flowing from the JoJo, what we do? We'll add the amount of water here and the amount of water here. That then will get the total. So that is what is happening. If we want to know the total current circulating in this electric circuit, what we do? We add the current that we got here and the current that we got here. And that current is what? Is 5 plus 7,5. Well, good, right? Okay. So now, let us deal with the third one. The third one, whereby we are requested to calculate the what? The internal resistance. There is something that I want you to look. Tell me, what is the V internal? Can someone tell me, what is the V internal? The voltage which is lost because of internal resistance. We don't even use a formula, we look at it and we get. But I know you're going to get it using a formula, it's correct. But I want you to come to this level of thought where you are very fast. Look. The battery had how much? At 24, right?
Yeah.
And the external resistor, they've got what? It means the lost volt is how much? 4. It's 4. It's 4. It means it's 4V. V external. You see? I know you can get it using a formula, but I want you to be fast, to go to become like robots. You understand? So it means the battery was delivering 24, but it could not. Some of the voltage were lost because of internal resistance. So it means V internal is just what? 4. You understand, right? Yes. So it means we can get it using like a simple formula. It means we can say, remember, V internal is equals to I, small letter R. This I is the total current, right? What is the total current of that circuit? So it means we can say 4 is equals to the total current. The total current, here when we calculated the current that is here, we got 5, right? Yeah. When we calculated the total current that is here, we got 7,5. So it means the total current of the whole circuit is 5 plus 7,5, which will give us 12,5. Then R. Then it means if we want to get the internal resistance, we just divide that by 12,5. And the answer is 0, 0.32 ohms. It is very easy to get it, you understand? Yes. I know that you got it, but you used a very complicated way. You went to the north and you came back and went to the south. You went to Zimbabwe, then you came back and I know that's what you did. Why? You can just simply get it, just simple. It is very important for you to exhaust this interpretive way of getting answers, you understand? Because another day you'll be given a tricky question whereby the formulas will not work. You will need to use the theory. As I'm telling you that the battery could deliver 24 volts as the maximum energy, but the external resistance, which is the V load, they only recorded how much 20, meaning 4 was lost. Understand? Okay. So, okay, let's just exhaust it using your methods. We use your own methods. What did you do? You said E is equals to V is equals to I, then R plus R, right? Yes. And it's a long method because in order for you to calculate total resistance, you need to go to RP. It's long, né? Remember, when you calculate total resistance in a circuit which have got the resistors which are connected in parallel, we don't just say this resistor plus this resistor. Remember, right? We need to say 1 over RP. We calculate for RP. RP, which is the total parallel resistance. So we can do that. Did we calculate the resistance that is here? What about here? No, no? We didn't calculate. Let's just calculate it. Let us use this page. This is another method. Although I'm done, I got it using just a simple formula, just like that. Okay. So if you are watching this and you're a curriculum advisor or something, please, sometimes when you are allocating marks to learners, you find that a learner can use a very simple step to get the answer as we did. And you find that there is no mark allocation for citing. Please don't focus on the mark allocation. I think it's unfair for the learners because some learners are very intelligent. They just do something which can take 5 minutes. They do it in 1 minute and they're done. And you make them omit marks, which is unfair and it's wrong. It must be changed. Please, so curriculum advisors, check that. Thank you. Okay, we're good, right?
Yeah.
So now, we want the resistance here. So it means the resistance is equal to V over I, right? Which is the voltage is 20, the current there is 5, right? Resistance will be 4. So it means the resistance here is 4, right? Meaning that we can even calculate the total resistance in this circuit, right? Yeah. Remember, I will always repeat that we are excluding this because it is open here, there is no current that is flowing. So we're going to have 1 over RP, which will become 1 over 4 plus 1 over 2,67, right? Yes. 1 over RP. When we punch this on the calculator, what do we get? Cross multiply divided by denominators multiply together. We'll get 667 divided by 1,000. 1068. But this value is very big, but it is correct. But I didn't get it in that way. So then we're going to have 1068 is equals to 667 RP, right? Yeah. Then we divide by 667, we divide by 667. Then RP is equals to 1,6. You all got 1,6. Okay, it's fine. It's 1,6, right? Yeah. So it means we're going to have 24, which is the EMF, right? Yeah. Which is equal to total current, which is 12,5. Then we will have 1,6 plus R. We're good, right? Yeah. Then we're going to have 24 is equal to 12,5 multiplied by 1,6 will give us 12,5 multiplied by 1,6 will give us 20. 20. Then plus 12,5R. Then we're going to have 24 minus 20, which is equal to 12,5R. Then we're going to have 4 is equal to 12,5R. Then we divide by 12,5. We divide by 12,5. Then R is 0,32 ohms. Hey, it is very long. It can cause you to even use up your time which you were supposed to use in solving other questions, because our exams are timed, right? So we must always choose the method which is fast so that we don't waste time. But if you don't understand that simple method, please don't hesitate, my people. Use the long method and you get the same marks as the person who used short method. Ladies and gentlemen, I'm happy to announce to you, as far as electricity is concerned from the teacher's perspective, we are done. Tomorrow we'll be doing questions and you guys, you will be solving those questions, and myself I'll be supporting you, walking around, assisting you. So from the teacher's perspective, we're done. We no longer teach using the teacher-centered method. It will be learner-centered now. So we'll be done with electricity. If you are watching this, don't forget to subscribe. Don't only subscribe, share these videos with someone, that people who are doing some supplementary exams. Share these videos with them so that they can pass. To support this channel is just subscribing and sharing it with someone on WhatsApp, Facebook, or anything. If you have a question, just write the question on the comment. Thank you.